Hey, Physics 30. Today we're going to be doing our lab on determining the magnetic field strength of two sets of magnets. On this lab, we'll be changing the current within a wire that is between the two sets of magnets, and then we'll change the current and measure the force that acts on them. So we have already talked about how the hand rule can be able to determine the direction. And we've probably already done some formulas and some math about how do we discover or how do we find the force. But today we're going to find the magnetic field strength between these two magnets by using the force, the current, and the length of the wire between them. All right? So let me just show you what the setup looks like, and then we'll talk about what we're going to gather. Okay, here's our typical hand or setup that we have here. We have our power supply, we have a scale, we have our magnet and our wire system, and then we also have our ammeter here as well. All right? So what's happening in this system here is that we have current flowing out through the system, through the ammeter, through this wire, and through a wire that is between two magnets. And you can see that that wire is technically not touching the two magnets. It's getting close, but not quite. And then it's going to pass between the two magnets because the magnetic field would be produced there. And then it's going to come back through to the power system. And what we're going to do is we are going to change the current, and then we're going to measure the force, and then we're also going to measure the current on this ammeter here. Okay, so you can see that I've stabilized the camera. I'm keeping the setup the same as it was before. And what we're going to do now is we're going to just talk a little bit about what's happening here. So over here on the left side, we have our power supply. I'm going to be changing this power supply, therefore changing the current. So I'm going to manipulate the voltage and manipulate the current. And then the current is going to flow through the system, through the black wire, through the ammeter, which is going to measure the current. You're going to notice that the two measurements between these two devices are different. The one on the right is going to be the more accurate measurement system. And this one here, you never trust the current readout on a power supply itself. So after it travels through the ammeter, it's going to go through this red wire. It's going to travel through the magnet system here. And then when it travels through the magnet system, the current is going to be flowing towards the back wall there. It's going to come out the back side and then continue its path and finish off in the power supply. So I'm going to be using my hand rule to figure out what's the direction of the force on the wire. So the current is going to go in towards the back wall there. This side over here is my north side of the magnet. This is my south side of the magnet. So I'm going to rerun it from north to south. My hand is going to go this way. And then you can see that my palm is facing upwards. So the wire is going to get pushed upwards. But because that wire is attached to this retort stand here, it's not going to move anywhere. That's not going to change. But because of Newton's third law, if the wire is forced upwards, the magnet system, even though it's not touching it, is going to be forced downwards. And you can see that as I change the current here. So you can see my current on this side is 0.93. This over here says 0.4. So the 0.94 is the one we're going to use. And you can see there's a force now of 0.0041 newtons. So the force downwards being registered here. And this is measured in newtons. Okay. So this is the lab we're going to continue or complete. You can see I've pre-made a table here for all our current measurements. Then we're going to go from 0 to 3 amps. This is just a rough draft. So we got current that we're going to manipulate, the magnetic force we're going to measure. Okay. All right. So I've zoomed into the experiment a little bit here, so we can see our amp meter displayed clearly, and we can pretty much see our newtons here measured clearly. The decimal on our newtons is right here. So this is 0.0001 right now. I'm just going to zero that out. So we're going to start fresh. So our current is 0 and our newtons is 0. So I'm going to put that into my table here. Okay. So now I'm going to increase our current until this says 0.5. You can see that it's quite finicky. So we're going to get as close as we can to 0.5. Now, you never have to be pigeonholed in doing exactly 0.5. So you're going to get a number that's close to 0.5, okay, such as this number here. And then we are going to record our result. So we're going to record both those numbers. So we have 0.054 and our magnetic force 0.0021 newtons. Okay. Now we're going to change it again. So we're going to increase this to 1.0. So we're going to just keep on increasing our current by half an amp each time. We're going to get as close as possible. And you can see I got 1.05. So I'm going to write down 1.05. You can see that I've changed the numbers on my table here. I've added extra digits to the back to make sure our current matches. Oh, you can see it changed to 0.6 there. You'll see my current change periodically because as the wire system heats up, my current will increase because resistance goes down. All right, so then we have a force here of 0.0044. Okay, so we're going to increase our current to 1.5 now. 1.5, oop, that's a little too far. Now, as the current gets higher and higher, my wire is going to get hotter and hotter. So that's why it's only suggested we go to 3 amps, plus the amps on the system or the fuse is only registered for a certain max heat here, max current. So that looks pretty good. So we'll go 5.5 for that one. All right. And then I'm going to have a force here of 0.0065. 0.0065. And then I'm going to increase my current again by another 0.5. As close as I can to here, close as I can to 2. What too high? Ooh, 2.03, sounds pretty good. And you can see my force here is 0.0086 if you can't read that. 0.0086. And increase it again another 0.5. Almost had it there. Okay, so I got 2.55, pretty close. And then I'm going to go 0.0108. So 0.0108 on there. All right, my last one, I'm going to just increase it to a 3. Oh, too far. Oh, here we got exactly 0. It's going up slowly as we talk here. So it looks like 3.0, and we have to be really quick about this. 3.07. Oh, went up again, 2.07, and then 0.0131 newtons. Okay, so far we've got our data. So this is what our data looks like here. Looking pretty good. And we're going to use that data to answer a few of these questions on the other side where we had to graph our magnetic force current graph here, and then use appropriate graphing analysis to determine the magnetic field strength between the two magnets. All right, that's up to you to do right now. And I'll see you next time.